Hello, in this video we are going to see some simple problems based on discrete random variables. If you had gone through the first link that has been provided, you would have gone through the basic definitions of a discrete random variable. It takes only countably infinitely many values or finitely many values. Now let us proceed with the problems. If x is a discrete random variable, if x is a discrete random variable, here on we will be denoting it as RV with with a probability distribution probability of x equal to x is some k into x for x is equal to 1, 2, 3 and 4. So x is taking only finite values. So find k and also find the probability of 2 strictly less than x less than 4, and also find probability of 2 less than equal to x less than equal to 4. The first thing is we have to find out k. So how do we go about this? We know that if f is a discrete random variable with this probability distribution, then my summation over I pi should be equal to 1. So let us first form the table for x and p of x. So the values are given to be x is equal to, you have 1, 2, 3 and 4. So substitute. So when x equal to 1, it will be k into 1, therefore k. When x equal to 2, it will be 2k. X is 3, it will be 3k, and x is 4, it would be 4k. Let us now find out the sum of these values to get the summation pi. So k plus 2k, 3k plus another 3k, 6k plus another 4k, totally 10k. Hence, my summation over I pi equal to 1 implies 10k equal to 1, or in other words k equal to 1 by 10. So this is the first value which we have got. Once we get this value, we can find the other things. So I have got my x now. I have also got the p of x now. My x takes values 1, 2, 3 and 4. So my p of x will be 1 by 10, 2 by 10, 3 by 10 and 4 by 10. You want to check if you are correct. Again here if you sum, your total will be 1. Okay, so now once we have got this, we need to find probability of 2 less than x less than 4. So between 2 and 4 there is only one number, and this is 3. So this is nothing but probability of x equal to 3, which is 3 by 10. Similarly, probability of 2 less than equal to x less than equal to 4. In this case, 2 and 4 are also included. Hence, it is probability of x equal to 2 plus probability of x is equal to 3 plus the probability of x is equal to 4. If you add, it is 2 by 10, 3 by 10 plus 4 by 10. Value here is 9 by 10. So this is how you find out the required details for the problem. Moving on to the second question. If the random variable x, if the random variable, always random variable is given by a capital letter, takes values 1, 2, 3 and 4 such that a relationship is given such that 2 times probability of x is equal to 1 equal to 3 times probability of x is equal to 2 equal to p of x equal to 3 equal to 5 times P of x is equal to 4, find the probability distribution, find the probability distribution of our random variable capital X. Okay, so we can start by giving one probability k and then finding out the relative values. So let me start. Let P of x equal to 1 be k. This is my assumption. Then what happens? I have 2 times P of x equal to 1 equal to 3 times P of x equal to 2. Therefore, I have probability of x equal to 2 is equal to 2 by 3 times x equal to 1 is k. Similarly, let us go to the second relation. 3 times P of x equal to 2 equal to P of x equal to 3. Hence, P of x equal to 3 is 3 times of 2 by 3k. I am substituting from the previous step, which is giving me the value as 2k. Then I have to find out the next value, that is, let us go here. P of x equal to 3 is 5 times P of x is equal to 4. Therefore, I will have P of x equal to 4 is 1 by 5 times P of x equal to 3. But P of x equal to 3 is 2k, therefore it is 2k divided by 5. Now if we clearly watch, we will be able to see that we have got x is equal to 1, x equal to 2 value, x is equal to 3 value, as well as x is equal to 4 value. So we may proceed with the writing of the table. How do we go about this? We have our x value and we also have our p of x value. So now consider this, we have our x value and we have our p of x value. So x takes the values 1, 2, 3 and 4. Therefore the corresponding values are k, 2 by 3k, 2k and 2 by 5k. Once you get the value, now there is nothing new about the problem. We revert back to the previous style. So now this gives us our x, my x value to be 1, 2, 3, 4. My p of x value, I think it is k, 2k by 3. Then it is going to be 2k and 2 by 5k. What do we know? We know that summation over pi equal to 1. So k plus 2k by 3 plus 2k plus 2 by 5k, this whole value equal to 1. Take LCM. Your LCM 3 and 5 are relatively prime, therefore it is 15. So I will have 15k plus 10k plus 30k plus 6k equal to 1. In other words, 15 plus 10 is 25 plus 30 55 plus 6 61. Therefore, k equal to 15 divided by 61. Now please substitute this value of k in the above table. That will give you the probability distribution. Hence, my p of x is now going to take the value substituting for k. K is 15 by 61. Come over here, it is 10 by 61. 2k, so 30 by 61. Again here it is 6 by 61. I want to check if my answer is correct. If I add everything, I should get a 1 here. 15 plus 10 25 plus 30 55 plus 6 61. So 61 by 61 is 1 and hence we are through. So this is the required probability distribution. This is the required probability distribution of our random variable x. I hope now you would have got a better idea of how to proceed with problems regarding probability distributions. Let us now proceed to the third problem. A random variable x has the following probability function. It has the following probability function. Find k, comma mean, that is the first order moment, and variance. Variance is the second order moment. With this can we find? Obviously I have not given the data. So given our x equal to minus 2, x is equal to minus 2, minus 1, 0 and 1, their corresponding probabilities p of x given by zero point 0.4, k, zero point 2 and zero point 3. Right. So before we proceed to the problem, we should know what is mean and what is variance. Mean, in other words, is expectation. Mean in other words is expectation. So mean equal to, in general, E of x. So what is this? This is summation xi into p of xi running over I. Similarly, my variance. Variance is, in other words, square of the standard deviation, or it is E of x squared minus E of x the whole squared. E of x you already have in the previous step, that is mean. So you only need to know what is E of x squared. So here E of x squared will be, if it is x, it is xi p of xi. If it is x squared, it is xi squared into p of xi. So these are the two main things or two main problems which we will be encountering in this problem. So now let us first take to it our x value. We will make a note of it because we have moved on to the new slide. So we have x, we have p of x. My x runs from minus 2, minus 1, 0 and then 1. I have 0.4, I have k, I have 0.2, I have zero point 0.3. I know that my summation over I, pi equal to 1. Therefore, zero point 0.4 plus k plus 0.2 plus 0.3 equal to 1. In other words, I have k equal to 1 minus 0.9, which is nothing but 1 by 10. Or this is 0.1 in other words. So I can replace my k in the above table. Next, my main concern is to find mean. So mean is nothing but summation x p of x over I. I have an xi and p of xi. So first value is minus 2, the corresponding probability 0.4 plus. The next is minus 1, the corresponding probability 0.1. Next 0, corresponding probability 0.2. Then 1 into zero point 0.3. Now this is minus 0.8 minus 0.1 plus 0 plus 0.3. Therefore, mean equal to minus 0.6. Mean can be negative. Next, I need to find variance. To find variance, I need to get E of x squared. This is summation over I xi squared into p of xi. So square your value. Minus 2 the whole squared into 0.4 plus minus 1 the whole squared into 0.1 plus 0 squared into 0.2 plus 1 squared into 0.3. So minus 2 squared is 4. 4 into 0.4 is 1.6. Minus 1 squared is 1. So it is 0.1. And then this becomes 0. And then you have a 0.3. So this value adds up to be 2. Next, I need to find my variance. Variance equal to, I have e of x squared minus I will have e of x the whole square. So what is this e of x squared? E of x squared is now 2 minus what is e of x minus 0.6. So minus 0.6 the whole square. So this gives me 2 minus 0.36 and variance is 1.64. Hence variance is positive and variance can never be negative because it is square of the standard deviation. Next, we will go on to another simple problem based on distributions. So let us take the random variable x, the random variable x can take the values, can only take the values 2 and 5. 2 and 5. Given that the value given that the value 5 is twice as likely as the value 2, determine e of x. So e of x is nothing but our mean, right? What is given here? I know that x takes value only 2 and 5, and also what is given? Probability of x equal to 5 equal to twice the probability of x is equal to 2. So let probability of x equal to 2 equal to some k. Then my probability of x equal to 5 will be 2k. Your table will be x and you will have p of x. So consider this table. Your values that x can take is only 2 and 5. So x equal to 2 is k, x equal to 5 is 2k. What do I know? Summation over I, pi equal to 1 or 3k equal to 1 or k equal to 1 by 3. This is our result. Once you get k equal to 1 by 3, I have to find e of x. So my e of x equal to summation xi into p of xi over I. Takes values only 2 into probability of x is equal to 2 plus 5 into my probability of x is equal to 5. Please come over here. Probability of x equal to 2 is 1 by 3 and 5 is 2 by 3. So it is 2 into 1 by 3 plus 5 into, if I am right, it is 2 by 3, 2k. So 2 by 3. Let us add, this is 2 by 3 plus 10 by 3, which is nothing but 12 by 3. Hence, my e of x value equal to 4. This is your answer. I suppose at the end of this session, you would have had good exposure to problems regarding distribution functions. Thank you.